Here's another example of an electromagnetic field revealing that the Sun has an electromagnetic field that stretches out throughout the entire solar system. The Earth has a magnetic field. When they interact, this is called the magnetopause. Around the Earth, as a tail stretches out for many millions of miles into space, and it's constantly vibrating and oscillating. This field nature of the universe is what we're only in the 20th century and the 21st century coming to realize. In the 19th century, and certainly at the time of Newton, the universe was seen just in terms of the bare bones of matter. Gravitation was what was the obsession of all astronomers. But this has, as it were, put the flesh on the bare bones of the gravitational view of the universe, showing the field nature of everything, of the Earth itself. Now, when we come to embryos, this is an embryo of a bat. All of this develops from a fertilized egg, which has very little structure to start with. How do all these different limbs, these structures come into being? What tells the cells what to do? The answer that within biology is now a very mainstream answer is the morphogenetic fields of the bat. That's what shapes it, that there's a kind of invisible shaping blueprint. Here you see a series of stages in the development of a nematode worm, a humble worm, with only a few thousand cells. It starts with an egg cell that divides in two, and then you see it going through a series of stages until this consists of many, many, many different cells with all different structures within it. These fields that shape developing organisms are different. Each organism has its own kind of field. And one reason why biologists liked and still like the idea of morphogenetic fields is because fields are intrinsically holistic. You can't take a slice out of the Earth's gravitational field. You can't take a slice out of magnetic field. If you try and cut the North Pole off a magnet, you just chop the North Pole end off a magnet, you don't end up with an isolated North Pole. You end up with two magnets, each with a complete magnetic field. Now, this is the very nature of fields. They're holistic, they interconnect, they give form, structure, pattern, and connect things together in a whole. If you cut magnets into little pieces, you get lots of little magnets, each with a complete field. Now, that's totally different from the way machines work. Machines are made of parts put together artificially in factories that work together in the entire machine, but it doesn't have an overall organizing field that makes it a whole. If you cut a machine up, a computer up into small pieces, all you get is a broken computer. So field phenomena are very different. And living organisms are much more like field phenomena than like machines. If you cut up a machine, you just get a broken machine. But if you cut up or damage an embryo, that's not what happens. Here you see a normal dragonfly embryo inside the dragonfly egg. In this one, the egg was tied off and this part was killed. The back half of the egg would, in a normal case, have just given the back half of the embryo. But in fact, this part of the egg now has a complete but small embryo within it. So by damaging this, this now has a complete morphogenetic field, like half a magnet. It has a complete magnetic field, and it leads to a normal embryo forming. No machine would do that kind of thing. We see the same with regeneration. If you cut a plant up into lots of little bits, each cutting can become a whole new plant. Willow trees are particularly good at forming cuttings, and you can make thousands of cuttings from a willow tree. This is a flatworm that, cut up into 3 bits, here, each of the bits can regenerate. The tail bit regenerates a new middle part and head. The middle bit gets a new head and tail. If you cut it acrosswise, you get a new worm. If you cut it in half, from top to bottom, it regenerates a new half. Each of these fragments has the field of the complete worm associated with it, just like a fragment of a magnet has a complete field, which leads to this regenerative healing process. These are limbs of a newt, and in this case, the newt's arm was amputated at this point here, On this side, it was amputated at this point, much further down. In both cases, the stump regenerates a whole new leg. And again, this is best understood in terms of the field which remains associated with the limb, even though the limb has been cut off. Now, we have much less regenerative capacity than newts. You cut off a person's arm, it doesn't regenerate. We do have, of course, regenerate in many of our tissues, the skin, the intestinal lining, the liver. We do have considerable regenerative powers. Without them, we wouldn't heal after damage. But less than a newt. However, I think even human beings, after losing limbs, still have the field of the missing limb, and I think that's what underlies the phantom limb phenomenon. I think people with phantom limbs are feeling the field of their missing limb. It's where the limb should be, and that's where the phantom's experience. People can move around their phantom limbs. And one of my experiments at the moment is trying to detect phantom limbs, the field of the limb. You can read about that in my book, 7 Experiments That Could Change the World. It's a very good, very simple experiment, and any of you who are involved in subtle healing might like to consider trying it. It costs nothing, and it's fun to do. Here's a form of regeneration that's even more remarkable. This was done deliberately in the laboratory with the eye of a newt. The lens was surgically removed from the eye of a newt to produce a form of damage that would never normally happen in nature. What happens is that the edge of the iris forms a new lens and regenerates a perfect functional eye. Now, in the embryonic development of a newt, the lens does not form from the edge of the iris, it forms from a folding in of skin on the outside. So it's formed a lens in a completely new way from a different tissue from where it would normally arise from, showing that there seems to be a plan of the complete eye. That take away the lens, that plan is still there, and it enables the regeneration process to occur.